students, welcome to my channel G for Nepal, and today I am going to prepare the land flood susceptibility mapping using GIS, in which I am going to use AHP and MCDA technique to prepare this map. First of all, flooding is a natural disaster that causes the damages to different sectors and severely affect the economic and social activities. And in this video I am going to prepare the flood susceptibility map using 8 criteria, and for these criteria I use slope, topographic wetness index, elevation, rainfall, NDVI, and similarly distance from river and distance from road, land use, land cover. And to do this analysis you require the dam data. From dam you can make the slope map in percentage. Here this is my slope map, which is in degree. Similarly, this is my topographic wetness index map. This is the dam of Gulmit district, so I prepare the elevation map from dam, and this is my rainfall data. And this is my NDVI, normalized difference vegetation index. This is land use, land cover map, and this is distance from road map, Euclidean distance of road. And my study area is Gulmi, which lies in the western part of Nepal. And this is all my study area, and this is the road network. And to make this MCD analysis, first of all you check the cell size. To check the cell size, go to properties and then source. Inside this there is cell size, and I made all the cell size is same, that means 30 meter for all the criteria here. And after that you need to reclassify all the factors as a required number of classes that we are going to prepare the flood susceptibility map. And in this video, this is my reclassified topographic wetness index map, in which 1 is lower susceptibility and 5 is higher susceptibility ranking inside the topographic index map. So the topographic wetness map, and I'm going to make the analytical hierarchy process ASP table here by using Excel. And this Excel sheet that I have prepared, I'm going to place it in comment section, so you can easily download from there. And in this section there are criteria, and then there are importance range, and there is scale value. For example, I'm compare the topographic wetness index for each the factor that I am used in this analysis. For example, topographic wetness index, that means A, and other factor, that means B. Which one is more accurate? If topographic wetness index is more accurate than elevation, then I use A in these more important categories. And I have provided the number scale range. It is between the 1 to 9, and if I put there 1, then it tells us the equal importance. Both factors are equal importance. If I write 3 for scale value, then it tells the topographic wetness index A is more important than B, by the scale of 3, and so on. I use 5 for strong importance, 7 for very strong importance, and 9 for extreme importance value factor. In this case I use the 3 value for topographic index. Wetness index is 3 times moderate importance than the value of elevation. As you can see, the table of AHP value for all the criteria has been changed now. If you are going to put the scale value and then criteria, importance criteria, then the automatically my AHP table is updated. For slope I use the equal importance, that means 1, because for flood analysis, flood susceptibility analysis, slope and topographic wetness index is equally importance, and I skip this part to calculate the AHP table. Just for example, I do for 2 categories, and I have also prepared the weightage from this AHP table. Here topographic wetness index have more weightage, that means 16% in percentage, and then elevation for 14%, slope for 12, precipitation for 16, LVLC for 9, NDVI 16, distance from river 16, and at last distance from road is 8. Also I have prepared the range, that means topographic wetness index, that 16 weightage is also divided into 5 equal classes. That means inside the parameter we also reclassified in 5 classes. That means it says the susceptibility classes between the range. Here in topographic wetness index, the value -13 to -6.9 is said to be very low susceptibility for topographic wetness index, and provide the susceptibility class rating is 1, and similarly for all. This is my topographic wetness index map in GIS, and that one is the value for susceptibility classes inside the topographic wetness index. Now you need to reclassify for all the parameter here and make the reclassified map as your required number of classes. In my this video I use 5 classes for susceptibility classes. Then after you go to weighted overlay tool. In weighted overlay tool you can overlay all the parameters and all the influence percentage, and for the weightage value for each classes here. For example, I'm going to add the topographic wetness index here. That means 1 to 5. This one is my reclassified value, and I put the scale value for all the classes. That means 1 to 5. Let me update all the factors here. Okay, these are my reclassified factor. As soon I already completed this part. Now I'm going to put the scale value for each classes inside the factor. Here 1 means in topographic wetness index, 1 means the lower uh, ranking class. That means 1 means lower topographic wetness index value, and it is compared with the susceptibility scale zone. Here lower weightage of the topographic wetness index takes the lower susceptibility, that means 1. So lower value gets 1 scale and higher value gets higher scale. So I put 1 for 1, 2 for 2, and so on. That means higher the value of topographic wetness index, higher the susceptibility zone. And similarly for slope, higher the slope, lower the flood susceptibility, and lower the slope, higher the flood susceptibility. So I put 1, I put 5 for lower the slope, and I put 1 for higher the slope. So I reverse the number: 1 for 5, 2 for 4, 3 for 3, 4 for 2, and 5 for 1. Similarly for elevation, lower the elevation, higher the flood susceptibility. So it is similar like this slope. And for rainfall, higher the rainfall value, higher the susceptibility; lower the rainfall value, lower the susceptibility. So this is this may not be changed in rainfall. For NDVI, higher the NDVI value, lower the susceptibility. As you can see in the table here, higher the NDVI value, lower the susceptibility, and lower the NDVI value, higher the susceptibility. So the value gets reverse in this case. So 2 for 4 and 3 for 3, similarly 4 for 2 and 5 for 1. And from for distance for road and river, nearer the distance, higher the susceptibility. So in this case, 1 means near distance from road, so it gets 5, that means higher susceptibility value. But at first my declassified map of river, that has some problem, because I do it in 5 classes. I did it for 5 classes, but here there is more than 5. But I put no data value uh, for all the value beyond my classes. So I put no data value for these classes. You have to clear that how many classes that you have categorized the weightage. And for river, nearer the river, distance from river, higher the susceptibility. So it gets 5, similarly 4, and then 3, and then 2, and last 1. Okay, move for next. That means land use. As you can see in the Excel sheet, the water body, agriculture land have high susceptibility. Water body have higher the high susceptibility in this case. And agriculture for high susceptibility, that means it gets 4 value, and so on. Here you need to check the symbology of land use. So I am going to check the symbology of land use. Okay, that means 1 means agriculture area, here 2 means barren area, 3 means build up area, 4 means forest area, 5 grassland, 6 swampland, and 7 water body. Here 7, here there are 7 classes, and in this declassified there are 8. There is height of 7, there in total 7, and there is 6, and after 6 there is 8, there is no 7. Okay, no problem. I'm going to change the value inside the classes. At first I'm going to put the water body for higher susceptibility. It gets 5. Okay, fine. Similarly, agriculture land get 4 value, high susceptibility, that means 1 get 6 get 1. 6 means swampland, that means vegetation area gets 1, low susceptibility, and also forest get 1. Okay, fine. And then build up area mean get moderate susceptibility zone, barren area get high susceptibility zone, and agriculture area get high susceptibility zone in the case of land use. But in the case I'm going to prepare the reclassified value of land use. So I go to search box and then type reclassify. Because there is problem of number of classes, so I'm going to change this. is a class name. Agriculture area 1, build up barren 2, build up 3, forest 4, grassland 4, swampland 4, water body 5, and no data is also no data. Reclassified land use. Okay, then click OK. Okay, I'm going to add this value. Now I'm going to add the weightage percentage. Now 1 means agriculture area. Agriculture area gets higher the susceptibility. As you can see the table, there is the 1 value, that means agriculture area gets high susceptibility, that means 4. So 1 get 4. Similarly, barren area get low susceptibility, that means 2. 2 get 2 is fine. Similarly, build up area get 3 for 3 fine. And vegetation, that means forest, swampland, grassland, vegetation get very low susceptibility, that means 2. So vegetation get very low susceptibility, that means 1. And water body very high susceptibility, that means 5. Four get 1, and then 5 get 5. Okay. And then you need to fill the weightage percentage, that means influence percentage value. As you can see, topographic weightage index have high susceptibility, that means 16%. Similarly, I'm going to put the value for slope 12. And for elevation, the influence factor is 14. For rainfall, influence factor is 16. Precipitation, for NDVI is for 16. Similar distance from road and river, that means distance from road is 8, and then distance from river is 16 or so. And at last, for land use is the usage percentage 9. There is some problem that the sum of influence factor maybe need 100%, but there is 107, so there is a problem. And in my case, I skip the calculation part for this video. If I sum the value, there is a 107, so there is mistake, so I skip this part. And after getting the result, there may be there is mistake in NDVI, so I subtract this 7 value from NDVI. So NDVI gives 9 weightage. Okay, I see the influence percentage is 9 from 16. Now is it correct? And after that, I'm going to set the output raster inside the floor susceptibility folder, and rename it into FSM floor susceptibility mapping.gif. Then click OK. And this is my final susceptibility map using 8 criteria. Here, final susceptibility map is categorized into 5 classes, in which one have low susceptibility, low floor susceptibility, and then 5 have high susceptibility. In color, red color have low susceptibility and green color have high susceptibility. So I change the symbology color here. Here green color shows low susceptibility and red color shows, and there is no need of reverse the color because higher susceptibility is shown in red color and lower susceptibility is shown in green color. Here the red color shows the higher susceptibility of flood, and then yellow for susceptibility, high susceptibility of flood, and red for very high susceptibility for flood, and yellow for moderate susceptibility, and light green for low susceptibility for flood, and green for very low susceptibility of flood. So by using the 8 parameter, I do the analysis of flood using ASP and MCDA technique.